Welcome to section 3, training a supervised learning model. This is lecture 12, improving the XGBoost model through hyperparameter selection. So if we pick up where we left off in lecture 11, we made use of a XGBoost classifier out of the box. So it was a baseline model. We didn't supply any hyperparameters to the implementation. In this case, what I've done is I've now trained the XGBoost classifier with the scale pos weight hyperparameter set to 100. So you can think of this as equivalent to the class weight hyperparameter that we made use of with the logistic regression model, where we are going to be penalizing misclassifications of the positive class more severely by a factor of 100 at training time. Hence telling the model, pay more attention to the positive class, which is, positive fraud. It's the minority class. And, we're just upscaling it by a factor of 100. Then once I've trained the model, making predictions, printing out the confusion matrix, and again, we can see, we're getting quite good results with the XGBoost classifier. We've got I think in the first baseline implementation, we detected 40 instances of fraud. Here we've got 41, but slightly more misclassifications from a false positive perspective. So yeah, I guess that's a good result, but we are able to improve it slightly. So let's look at what else we can do. In a second iteration of hyperparameter tuning for the XGBoost model, I'm going to keep the scaling of the positive weight hyperparameter to 100. Then I'm also going to introduce this maximum depth hyperparameter, and I'm going to set that to 5. And what that effectively represents is the maximum depth to which each of the smaller trees within this ensembled approach, it specifies how deep each of those trees will be built, or how deep they will go. And it's an approach to reduce overfitting as well. So that's something we can, dial up and down. We can, make the maximum depth, something like 2 or 3 if we want. Maybe there's not enough complexity there. Maybe if we set it to a depth of 10, that's likely to be too deep. We're going to experience some level of overfitting. So we have to find that happy medium point in conjunction with different values for the scaling of positive weights. So you can imagine how this becomes quite a big optimization problem, because if you increase this to 6 or 7 and we keep that 100 as is, it might improve the model. And then if we drop 100 again, then maybe it reduces the performance of the model, etc. So you're often making trade-offs with one another. But what you want to do is take an approach where you can explore within reason the universe or the possible space of different hyperparameter configurations, and then see what you kind of come up with, and that can be run as an experiment. And like I mentioned, there are tools like HyperOpt and OptTuner that allow you to do that. So once we've trained the second model, we can see that we're getting better results from a positive class classification performance. So we're detecting 2 more fraudulent instances, and we've got less false positives. So there's only 3 non-fraudulent transactions that we've flagged as fraudulent, which seems like a better result.